Most teams add more agents to get more power. That's the mistake. The architecture that actually holds isn't the one where agents talk to each other the most. It's the one where the coordinator is protected from everything the subagents produce. 3 load-bearing invariants. The Claude Certified Architect exam tests all 3. You'll know them in 7 minutes. Welcome to AI Techbook. This is the Claude Certified Architect Foundations exam prep series, Domain 1, Agentic Architecture and Orchestration. 27% of the exam, today. The hub and spoke pattern, the coordinator subagent architecture, and the 3 invariants that make it hold. You have a task that's too big for one model call. You have multiple capable agents. What's the right way to connect them? This is the hub and spoke pattern. One coordinator at the center, the hub. Several subagents around it, each in its own isolated context, the spokes. The coordinator's job has exactly 3 parts. First, decompose. Break the task into scope pieces, 1 per subagent. Second, delegate. Send each subagent a task prompt. That is the entire handoff. Third, synthesize. Receive the summaries, build the final output. The coordinator does not execute work. That's the design. Every token the coordinator processes directly is a tension budget it spends. Every token a subagent processes internally, the coordinator never sees it. That's why the pattern scales. 5 subagents working in parallel on 5 isolated tasks, each returning a roughly 1,000 token summary. The coordinator receives 5,000 tokens of distilled intelligence, not 5 context windows of noise. For mid-complexity research queries, the lead agent typically spawns 3 to 5 subagents in parallel. For simple tasks, 1 agent. For complex research, 10 or more. The coordinator decides the count based on task complexity. On the exam, the coordinator's role is decompose, delegate, synthesize, not execute. That distinction appears directly in the questions. 3 things keep this architecture from collapsing. They look like options. They are load-bearing walls. Remove any one and the whole structure fails. Invariant 1, isolation. Every subagent starts with a clean, fresh context window. It doesn't see the coordinator's history. It doesn't see what the other subagents are doing. It sees only what the coordinator put in its task prompt. Invariant 2, summary not pile. Subagents return condensed results, not raw artifacts. The subagent may process 50 pages of documentation internally. What it returns? A distilled summary, typically 1 to 2,000 tokens. The coordinator receives intelligence, not a data dump. Invariant 3, 1 channel, the task prompt. There is no shared memory. There is no global state. There are no side channels. Every piece of task-specific information the subagent needs must be packed explicitly into the delegation prompt, or it doesn't exist. And the subagent's results travel back through 1 channel, the summary it returns. These 3 aren't independent. They reinforce each other. Isolation makes summary not pile possible. Summary not pile enforces the single channel. The single channel makes isolation auditable. Together, a reliability architecture. The exam tests all 3 individually and in combination. Why does isolation matter this much? Because without it, the coordinator accumulates noise faster than it can process signal. The attention mechanism computes relationships between every token in the context window. Every token attends to every other token across the entire context. That's in squared pairwise relationships for in tokens. At 50,000 tokens, that's 2.5 billion in 90s K's. At 200,000, 40 billion. Past a certain density, earlier context starts dropping out. The model literally cannot hold everything simultaneously. What engineers call context rot. Accuracy degrading as the context window fills. Isolation prevents the coordinator from reaching that density. All of each subagent's working context stays inside that subagent. The coordinator's budget stays under control regardless of how much work the subagents do. Now the performance numbers. For complex research queries, parallel subagents cut research time by up to 90%. The cost. Multi-agent systems use roughly 15 times more tokens than standard conversations. That's the trade. Up to 90% faster in exchange for 15 times more tokens. And here's the finding that ties them together. Token usage alone explains 80% of the performance variance, not model size, not prompt complexity, how many tokens the system uses. Isolation is what makes the 15 times cost manageable. Instead of the coordinator processing all those tokens, each subagent processes its share in its own window. The coordinator's window stays clean. 2 layers of isolation to know for the exam: the context window layer, which we just covered, and the tool layer. Each subagent gets only the tools its task requires. A subagent that can only read files cannot accidentally delete one. That is blast radius control at the action layer. The coordinator hands a task to a subagent via a prompt. What should be in that prompt, and what should come back? 2 questions, 2 invariants. Both have specific, verifiable answers. Let's start with what comes back. The subagent receives a task prompt. It may process 50 pages of documents internally. What it returns: a condensed summary, typically 1 to 2,000 tokens, of its conclusions. Not the search results, not the intermediate reasoning. Just the distilled output the coordinator needs to synthesize. If the subagent returns its full search history, the coordinator's context fills. The coordinator degrades. That's the context piling failure mode, and it's invisible. The coordinator keeps running. It just produces worse output. Now, what goes into the delegation prompt? Anthropic's multi-agent research describes 4 required parts: objective, what the subagent needs to find or do; output format, how the summary should be structured when it returns; tools, which tools and sources the subagent should use; scope, what is in bounds and what is not. Missing any of these produces one of 2 failure modes. Missing the scope, 2 subagents investigate the same thing, duplicated work. Missing objective clarity, a whole area of the task falls through the cracks, a coverage gap. The exam tests this, and it asks which part of the delegation failed, not which subagent failed. The error is always in the coordinator's decomposition, not in the subagent's execution. 3 failure modes. Each one traces directly to an invariant violation. The Claude Certified Architect exam tests whether you can diagnose which invariant broke. Failure 1, context piling. A subagent returns its full working context instead of a summary. The coordinator's window fills. Performance degrades. No error is thrown. The coordinator continues. This is the dangerous failure, invisible until someone reviews the output quality. The broken invariant, summary not pile. Failure 2, flat topology. All agents communicate with all other agents. Every agent sees every other agent's context. The isolation invariant is gone. The coordinator's attention is split across all channels simultaneously. The architecture Anthropic recommends is hub and spoke, a central coordinator, precisely because flat topologies produce exactly this failure. The broken invariant, isolation. Failure 3, weak delegation. The coordinator's task prompt is missing the output format, or the scope is ambiguous. 2 subagents investigate the same subtask. A domain goes uncovered. This is the exam's most commonly missed distinction. The error is in the coordinator's decomposition step, not in the subagent's execution. Subagents executed correctly. The coordinator set them up wrong. The broken invariant, the one channel, specifically, what went into it. One more constraint that appears on the exam: subagents cannot spawn other subagents. This is a hard system constraint, not a guideline. It prevents unbounded recursion and keeps blast radius bounded. If a workflow needs nested delegation, the answer is to chain from the main conversation, not to work around this constraint. The exam rule: name the failure mode, identify the broken invariant, prescribe the fix. Every multi-agent problem on the CCA-F maps back to isolation, summary not pile, or one channel. The hub and spoke pattern: 1 coordinator, scope subagents, 3 load-bearing invariants. Isolation, summary not pile, 1 channel. If you're continuing your Claude Certified Architect Prep, the next unit is task decomposition, how the coordinator actually breaks a goal into scope subagent tasks, and the scaling rules that decide how many subagents a task needs. Subscribe so you don't miss it. And if this cleared up the pattern for you, share it with someone building their first multi-agent system.